Okay, simplifying rational expressions. So a rational expression is said to be in simplified form when the numerator and denominator have no common factors. Okay? So to simplify a rational expression, first thing you do is factor both the numerator and the denominator completely. Then we always state restrictions, right? And restrictions are always stated from the factored form of the denominator. Okay, so if you don't have to do any factoring, then your first step would be to state restrictions. Otherwise, factor numerator and denominator, state the restrictions, and divide out the common factors between the numerator and the denominator. That's it for simplifying. Simplify. So if we have monomial rational expressions, if you have numbers, you can simplify them just using your calculator. So strip out the numbers. You can go 15 divided by 10. Math, enter, enter. If you like, you can recognize that 5 goes into those. But 15 divided by 10, and if you convert that to a fraction, so math, enter, and then enter again, you get 3 over 2. Now, to simplify the variables, what I always ask is, who's bigger? So which one's bigger, top or bottom? Top. How much bigger is the top than the bottom? 4. So the top wins by 4. Right. So we have 3x to the 4th over 2. 24 over 40. Okay, so same deal. You can use your calculator. 24 divided by 40. Math. Enter, enter. 3 over 5. Who's bigger, top or bottom? Bottom. By how much?
3.
By how much?
4.
4.
Sorry, I thought it was 5.
Okay, so you do the last one. And the forgotten step, because there was no factoring involved, so I can't skip the step, which was state restrictions. So restrictions are always stated after it's factored, it needs to be, but before it's simplified. Okay, so before it's simplified. So we look in the original expression, we've got a 10x in the bottom, so x cannot be 0. Look in the original, we've got a y to the whatever, 6th, so y cannot be 0. And we look at original, or even in the simplified form of the last one, still x cannot be 0. Okay. So what this is saying is these are equivalent. This is the same as this for all values of x, as long as x is not equal to 0. Okay. So if you put x is 3 in here and work it out, you'll end up with the same value you would get if you put a 3 for x in here. Because they're equivalent. So they're, not only is it simplified form, they're also equivalent rational expressions, right? But the main reason we do the equivalent rational expressions, so the first section we did on Friday, is for adding and subtracting. Okay? So any of you that missed Friday, just make sure you're up on equivalent rational expressions by Wednesday. Okay, you'll be okay. Okay, everybody get 4 over x? Simplify binomial numerators. Okay, so we do have to factor, right? In this case, denominators won't be factored, so we could just state non-permissible values. Let's just do that first. Nice thing about monomial denominators is it's just the variable can't be 0, right? That's always the restriction. Okay. There's no factored form of that. It's not a binomial. There's no two terms. We don't have to solve anything. Okay. Just say, hey, the variable can't be 0. All right. So factor the numerator. Step 1. Factor the numerator. Rule down factoring. So this is just common factoring. Okay, when you have factored, you do two things. You multiply it back in. Right? It's not foiling. There's no 4. It's not binomials. Right? It's just distributive law. So 10x squared times 3x is going to be 30x cubed plus 40x squared. So in other words, just make sure the factorization is correct. If it's wrong, then it's just wrong. Right? The whole thing is wrong. So always check your factor form. Then we simplify, right? So x squared and x squared. Just divide out. And the 10 over 25, you can do it on your calculator if you like. You do just by saying, well, 5 goes into this twice, into this 5 times. So I'm left with 2 times 1, so 2 times 3x plus 4 over, and on the bottom, 5. Okay. And you can get the 2 over 5 by going 10 divided by 25 math enter, right? Letting your calculator reduce the fraction for you. All right, any questions there? Keep going. All right, factor the numerator. Okay. Factor and then check. The other check is there anything that goes into 3 and 4? Whatever you've got here, you have to make sure there's no common factors in there. Right? Maybe you forgot to take out a factor of 2 that you should have. You just divided by 2 instead of dividing by 4. You divided by 8 when you could have divided by 16. So just make sure that it is the simplest form. What do we got? What goes into 20 and 12? So the restriction is just going to carry all the way through for the whole thing. Right? And restrictions always do. Right? The restrictions are done off of the factored form of the denominator, and in this case we don't have to factor, right? Okay, reduce. Okay, use your calculator if you want. 4 divided by 16, math enter. You can just do it. And then for the variables, it's always just who's bigger? Well, okay, the numerator is bigger. That's squared. How much bigger? Bigger by 1. Okay, so we're going to put an x to the 1 up top. That's how I reduce variables, right? It's like who's bigger and by how much? Denominator is bigger by 3. All right, then we put an x cubed or whatever in the denominator. Numerator is bigger by. Okay, keep going. Okay, denominator, nothing to factor. Factor the numerator. We've already stated restriction. That's the first thing we did, state restriction. time you factor, just multiply it back out. In this case, with the greatest common factor, just multiply it back out. Make sure the signs are correct. Usually that's where you go wrong. You'll have a sign that's incorrect. Anytime there's a negative in a fraction, put the negative up top. Or in the front. Never in the denominators. If there's a negative, put it up front. Or in the numerator. And one more. Again, restrictions hold all the way through. Especially important in A and B.
I think you made a mistake on the last one because you got rid of. It should be a 4.
Yeah, it should be a 4. You got that mistake. So the only thing that you can cancel top and bottom is a factor, right? So you can't cancel the 2 with the 4 in the last expression. You can't say, oh, 2 goes into 4. I'm going to reduce that or whatever, because the 4 is not a factor. It's not a factor of the top term, right? Factor is something that multiplies. So here, the 2 is a factor, right? This and this multiply together. They are factors. I can cancel factors. The 4 is a factor. I can cancel factors top and bottom. This is not a factor. It's part of the expression. Make sense? Simplify binomial numerators and or denominators. So first factor. Is there any factoring to do in A? Nope. State restrictions. What's the restriction? X is not equal to 4. And you can't. So there's a trick's not the word. There's a trick, it's not the word. There's something to look out for here, right? And here, so okay, 3 goes into 18. That's obvious, right? We're going to cross off the 3. We're going to put a 6 on the bottom. But 4 minus x and x minus 4, they're like almost the same, right? But one has a positive 4 and then minus an x, and the other one has a positive x and then minus a 4. So it's the same 2 terms, but they have opposite signs. So here's what we're going to do. We're going to factor a negative out of this term. And we're going to rewrite it so forget the 3x for now. I'm not interested in that. Right? I've got negative 1 times x. That's negative x plus 4. Okay. Well, that's what I want, right? I've got a negative x and then a plus 4. So now by taking a negative out, I've flipped this around so that it's now equal to this. Right? So these are now equivalent because I took a negative out. So these cancel. The negative stays. The 3 cancels. So I have 1 times negative 1 times 1, which is negative 1 over 6. So it's negative 1 over 6, right, like that, or negative 1/6.
Can you run through that again?
Oh, sorry, there's an x up top. Negative x over 6. Or negative. Okay, if I have the same two terms, I got an x minus 4 and I got a 4 minus x, right? And I say, one has a positive x and a negative 4, but the other one has a positive 4 and a negative x. So they've got the same two terms, but they have opposite signs. If I factor a negative 1 out, in other words, if I divide, so up top, if I divide 4 minus x by negative 1, then I'm going to change their signs, right? So I'll put a negative in front, and then I'll change the sign of what's inside, so the 4 becomes negative and the x becomes positive. Right? Just think about distributable. Anytime there's a negative in front of the brackets, you change the sign of everything in the brackets. So in this case, we're going to put a negative outside and then change the sign of everything in the brackets. Why do we do that? Because now those two binomials are the same and they cancel.
Isn't like anything you do to the top is to the bottom?
Nope, I'm factoring.
Oh, you factored?
I factored a negative 1 out.
Oh.
Okay. So I divided the brackets by negative 1, right? It's not an equation so that you do this, do that. It's just saying, is negative 1 times, so really, I guess if I'd have written it this way. Okay. Is this the same as 4 minus x? And you go 4 minus x. Okay. But by pulling the negative 1 out front, what I'm doing now is just kind of changing it to this form. You're going to see that, okay? Pretty much guaranteed. You're going to see that on the diploma. You're going to see that on, I guarantee you'll see it on the upcoming test and midterm and everything else, right? So it's just saying, got the same two terms, right? But I have opposite signs, so I can cancel them. So the short form way of doing this, really, is you look at this, and you just say, I'm going to cancel these guys, and I'm going to write a negative 1 up there. You just do that. Like first, you're going to do your non-permissible value. Okay, so that's here. So x is not equal to 4. Then you just say, hey, same two terms, opposite signs. I'm going to cancel them. I'll put a negative 1 there. I'll put a 1 there. So now I have negative x over 6. Okay. Non-permissible value. Okay, 0 and
Negative 0.66 repeating or...
Never do that, please. Negative 2/3. Never do that, please. Never do that, please. Negative 2/3. So fractions are exact. Fractions are always exact, and decimals maybe. So I mean, a half is 0.5. Even then, write it as a fraction. Okay. Does everybody see where we got the negative 2/3 from? Okay. So here's the deal, right? It's in a factored form. Okay. So all I do is say, okay, what value of x makes that 0? Okay, so that's the 0 part, right? Everybody good with that? 8x squared, x can't be 0. The other part is, so this will be the non-permissible value, right? If 3x plus 2 equals 0, that's what we call a non-permissible value. So then we solve that. So then 3x equals negative 2, and x is negative 2 over 3. That's the non-permissible value, and then we say not equal, that's the restriction. Okay? So that's how you do it. Easy way. So the easy way is to say, take this, switch its sign, right? Because basically this is going to move over here. So take that, switch its sign, it's going to be negative 2, and then divide it by that. Okay, that's what you do by solving, right? You move this over, that changes its sign, and then you divide by what's in front. Okay? So you can show that work if you like, and you can just go straight to the negative 2/3 if you like, doesn't matter. Okay. So we ask for restrictions. It's kind of like half mark off for each one that's wrong. Like if you leave some restrictions out, you're going to lose a half mark per. And if you put in restrictions that aren't restrictions, you're going to lose a half mark per. Up to a maximum of 1 mark, or whatever it is. So 8x squared and 8x squared take each other out. What about 2x plus 3 and 3x plus 2? Yeah, that's it. Okay. There is nothing to simplify. So it's not like here, same terms, opposite signs. It's kind of like same numbers, but they're flipped around. So they're just not the same, right? We can't cancel them. Okay, so in the first two, there was nothing to factor in the denominator. So now we can factor both numerator and denominator in part C. Okay. So before we can state restrictions, the other ones were factor, we could just go straight to restrictions. Before we could state restrictions, we have to factor. So factor the numerator, factor the denominator. This is just common factoring. Check. Okay, check. So in common factoring, the check is just to multiply it back up, multiply the two terms. Okay, so I think it's a 3x. I see a 3, I see an x. So 3x, x minus 5 gives me 3x squared minus 15x. Yep. 6 bracket x minus 5 gives me 6x minus 30. Yep. Then state the restriction from the factored form of the denominator. It's only the denominator, right? We don't care if x is 0 here. X can be 0. That's fine. We'll just end up with 0 divided by negative 30. Which is fine. That's just 0. And reduce. So the 3 over the 6, fraction part, you can use your calculator. You can just say, well, it's 1 over 2. The x minus 5's cancel. And we're left with 1/2 x, or x over 2. At any point, you have any questions, be sure to ask. Okay, try the next one. So factor numerator, factor denominator, state non-permissible values from the factored form of only the denominator. And reduce. Good. Not much to do there, right? X squared plus 16 can't be factored. That's a sum of squares. The only thing you can do with two terms when it's being added is to common factor. Right? And there is no common factor that goes into x squared and 16. 3x plus 12 we factor to help us get the non-permissible value, so 3 bracket x plus 4. And we got the restriction. X cannot be negative 4. We're done. All right, we got two more. Okay. Factor E. Factories. Factor the numerator, factor the denominator. Look. Get a box back. Hope there's like fresh water in there.
Oh, yes.
Good day. Okay, what's the factorization of the numerator? So check your factorization. Make sure there's no other factors. If all you factored out of the numerator was an x, then in your brackets, each term is going to have at least one x. And then you say, oh, It's not fully factored. So fully factored means whatever's in your brackets, there should be no common factor in there, right? They both shouldn't be even, they both shouldn't have an x, etc. So first you state the restriction, x cannot be negative 1/5. Or sorry, positive 1/5. And secondly, we go, hey, I got 5x minus 1. I got 1 minus 5x. Same two terms, opposite sign. The shortcut is cross them off, put a negative sign up top. I didn't actually cross them off, so I'm going to do that now, but just wanted to show you what the answer was. So, cross them off, put a negative 1 up top. We have negative x squared up top, get positive 1 on the bottom. We're in the denominator. Okay, any questions on that one? You're going to see it, so just watch out for it. Same two terms, opposite sign, cross them off, put a negative sign in place of 1. Move that out of the way. Alright, factor cancel. Oh, sorry, factor, non-permissible values. Cancel. Do, whatever. Simplify. Simplify. It's always the instructions, right? Instructions for all this will be simplify. That's all you can do, simplify. Okay. Tomorrow we'll do multiplying and dividing. The instructions will be simplify. Wednesday we'll do adding and subtracting. The instructions will be simplify. Today we're just simplifying rational expressions. The instruction is simplify. Okay. The only time we don't simplify is when what we were doing yesterday was find an equivalent, not yesterday, Friday, equivalent rational expression. And the reason we're doing that is so that when we add and subtract, we can get common denominators, right, which we know we need for adding and subtracting. So difference of squares, guarantee you're going to see some difference of squares on there. Then restrictions. Then common factors. Cross something off, just write a little 1 there.
Can we do that for D? Because 16 is the square root.
Yeah, but it's x squared plus 16, so it doesn't actually factor. Okay. So it has to be a difference of squares. X squared minus 16. Right. Otherwise, you get x plus 4 will give you x squared plus 8x plus 16, or x minus 4x minus 4. So two terms with a plus sign in between them, only thing you can do is common factor. You know, unless it's like, yeah, well, no, there still have to be a minus sign. If it was 16 minus x squared, that would be a difference of squares, right? So you still have that. All right. I think that's it. Is that it?